Welcome to GRO Mathematics and Statistics lesson. Today we will be considering Surds part 3, where we shall be discussing the basic form of a surd. So what is the basic form of a surd? Now the basic form of a surd is the simplest form of the surd, in which case the rational number under the root is not made up of factors that are perfect squares. Again, the basic form of a surd is the simplest form of the surd, in which case the rational number under the root is not made up of factors that are perfect squares. This definition applies to both quadratic and non-quadratic surds, okay? It applies to both quadratic and non-quadratic surds. You must take note of that. Although in this lesson we shall focus our attention on quadratic surds. And for more on quadratic surds, you can actually look up at our video on surds part 1. We really discussed quadratic surds there. So you look at that video and you'll be able to understand this better. Okay, so let's move to the next thing. Now, that being said about surds, the basic form of surd, how can we subject a surd that is not in its basic form to its basic form? So all we have to do is to follow the procedure as I'm going to show you below. Now, let's consider these examples. The root of 32 can be written as the root of 16 times 2. Take note, we chose 16 times 2. We could have chosen 8 times 4. 8 times 4 would have given you 32, but we chose 16 times 2 because when putting in a surd that is not in its basic form, all you have to do is to write that number, the rational number under the root, as a product of two numbers, such that one of those numbers is a perfect square and the other is not. So now I have written 32 as 16 times 2. By the rule of surds, this becomes root 16 times root 2, and root 16 gives you 4, so that becomes 4 times root 2, which is 4 root 2. Similarly, root 12 can be expressed as the root of 4 times 3, and we've chosen 4 times 3 because instead of 6 times 2, we chose 4 times 3 because 4 is a perfect square and 3 is not, and that gives you root 4 times root 3, which is 2 root 3, giving you this. Okay, so similarly, root 48 was written as root 16 times 3, which gives you root 16 times root 3. And that is because 16 is a perfect square, 3 is not. And that will reduce to 4 times root 3. And the result is 4 root 3. The same thing applies to root 50, okay? So what we are saying in essence is that surds in their non-basic form can be put in their basic form by following this simple procedure. Now, we can walk forward from a surd in its non-basic form to its basic form, and we can also walk backwards. So how do we move a surd from its basic form to its non-basic form? All you have to do is to reverse the procedure above. So what I'm doing here is this. 4 root 2 is a surd in its non-basic form, or in its basic form rather. 4 root 2 is a surd in its basic form. Now we want to walk backwards to getting root 32. How did we do it? All we have to do was to take the square of the square root of the square of 4 and multiply same with the square root of 2. That gave us root 16 times root 2, which by the rule of surd gave root 16 times 2, and the result was root 32. Similarly, root 3, 2 root 3 could be expressed as the square root of the square of 2 multiplied by the square root of 3, and that gave the square root of 4 multiplied by root 3, and that gives you the square root of 4 times 3, which is the square root of 12. Again, 4 root 3 can be written as the square root of 4 squared times root 3, and that gives you the square root of 16 times the square root of 3, which is the square root of 16 times 3, and that gives you the square root of 48. So you can actually walk forward and backwards from the non-basic form to the basic form, and the basic form to the non-basic form. So do like our video, share our video, and most importantly, subscribe to our YouTube channel for more videos on surds and other topics. Thank you very much.